record the meeting, and then, okay. And so here we have.
Great.
Okay. Thank you very much.
I will just interrupt you from time to time to go ahead, if that's fine with you, Alessandro.
Yes, sure.
Okay.
Yes.
Thank you very much. So today I'm going to tell you a few words about the Clisasgri that you are then going to see in the demo version in the dashboard. So the outline of my talk: first, I will say a few words about climate risk modeling in agriculture. Then I will talk about the motivation for the development of the agroclimate service that we named Clisasgri. Then I will present it. So I will talk about actually the actual functionalities of this package that we can use in R. And yeah, I guess this one will be a bit more difficult with the live demonstration, but I have also copied and pasted the code in the slides. So I guess if I cannot share the screen here, you will be able to see. I will be able to explain you just few examples of use of the R package. Okay, ahead. Next. So why is the climate risk important in agriculture? We know that the production, the agricultural production and productivity have both been increasingly exposed to unfavorable and extreme weather and climate events. We have seen this more often and often lately. For example, just this year, those of you that have been exposed to the cold spell of early April, you know that there was a lot of damage caused by extreme low temperatures in France, northern Italy, many parts of Eastern Europe. And it appeared exactly during the time that some fruit trees were flowering, and consequently destroyed a lot of yield. So yeah, that's why it's important that we understand these events and we understand how they are going to evolve also in the future in different temporal scales. We know that the future climate change is very likely to even exacerbate the intensity of these kind of extreme events. Cold spell that I mentioned was just an example, but we also have droughts, for example, heat stress, excessive rainfall, and all these factors are projected to increase in terms of frequency of occurrence, severity, and the spatial extent of impact of this kind of extreme events. So as I mentioned, a number of stress factors are very important that are affecting crop growth, and among the most important that I will also focus on today's talk are heat stress, drought stress, intensive rainfall events, and frost kill. Next, please. So just to illustrate, these are some recent trends that we have observed in Europe. On the left side, you can see the trend in crop water deficit for grain maize growth during the growing season. So here you can see the trends between 1995 and 2015. And you can see that the crop water deficit is increasing in many places of Eastern and Southeastern Europe, as well as in Northern Italy. Also well, we can see basically that a major part of Southern Europe is affected by this kind of positive trend, meaning that the maize as a crop, for example, is exposed more and more to the water deficit during the growing season. We know that in many of these regions, maize is irrigated crop, but you can imagine that in the future, with the lack of irrigation water, this can become an issue as well. While on the right side, you can see the trend in the summer soil moisture in Europe, which is again here. So this is given for the upper layer soil moisture, and it's a more generic indicator that is not crop specific. So here as well, we can see that the hotspots of the currently ongoing climate, let's say, change is mainly concentrated in Southern Europe. Again, we can see the Northern Italy, many regions in Southeastern Europe, the Iberian Peninsula, Southern France, etc. So here, all these are the regions where we can currently see that the water availability for agriculture is declining. Next, please. So the increasing risk, as we have seen, of crop failures that are related, for example, also to declining water availability, but not only to that. So I have mentioned also other abiotic stress factors such as heat stress, but also due to biotic factors. All these point to the need of joint modeling and efforts to better quantify and then predict the effects of these events during the sensitive periods of crop development. And for example, if we talk about wheat, we can see on the lower image. The lower image presents the share of Mediterranean arable land area that is affected by heat stress. With the heat stress here, I mean at least 2 or more consecutive days with maximum daily temperature above 31 degrees Celsius. And here we compare 2 periods. With blue line, we can see the area affected between period 75 and 95. And the red line, the area affected between 1996 and 2018. And you can clearly see, if we compare, for example, in the same period of the season, that the more recent period has exposed a higher proportion, higher share of arable land to a higher heat stress risk. But not only that, we can also see, for example, if we compare the arrows, that we can see the blue and the red arrows, where the color again corresponds to 2 different periods. These arrows represent the flowering time and on the left side, and the maturity timing on the right side. So for winter wheat, and we can see another factor as well, that winter wheat now generally flowers a little bit earlier as a response to increased temperatures with respect to the period in preceding 20 years. Nevertheless, what we can see here is that during the grain filling period and also during the flowering period, which is especially critical and sensitive to heat stress, there is an increased risk of having, let's say, heat stress that would affect the higher proportion of arable cropland in the Mediterranean area. And that's why this is one example why it is very important that we developed sectoral climate services to support and inform agricultural decisions, which will enable in the future to build more resilient, efficient, and sustainable agriculture. Next, please. So about the motivation, so now I have been talking about risks, and within the MedGold project, which was actually the parent project where we created actually the Clisasgri agroclimate service, we aim to assess the risks in agricultural production that are, let's say, ranging from several weeks to 1 year ahead, which means that we are addressing the so-called seasonal climate predictions. And we have also tried to understand how this kind of, let's say, risk assessment tools could be used with on different time scales, up to 10 years ahead or up to a century ahead. So if we are talking up to a century ahead, we are talking about the climate change impacts. Yeah, there are different, let's say, these assessments are different from the climatic point of view, because there are different mechanisms that are important on these time scales. And of course, when we build a climate service or risk assessment tool, we need to understand very well how to take into account these different temporal scales. So we have done so. We have, let's say, tried to bridge this gap by proposing a tool that is able to integrate observations and climate predictions and projections, meaning that we are able to integrate seasonal predictions, so going up to from a couple of months up to 1 year ahead, and also the climate projections. And what is also important, and I mentioned this several times already, we focused on sensitive phenological stages of the crop growth, which means that this effectively translates into the fact that we are not just talking about a certain month of the season and addressing, let's say, the climate risk within that month, but we are talking about a specific crop growth stage. This means that to do so, we have implemented a dynamic approach that is mainly temperature driven and calculates the phenological development from sowing and goes until the maturity of winter wheat. And by doing so, we can effectively then, as I will show you later, depict sensitive or more sensitive and less sensitive crop phenological stages during the growing season. Next, please. This is just an example to show you how our dynamic modeling approach is based. So phenological development is simulated as a response to temperature and day length. And the season is divided in two parts. So first part is generally the period between sowing and anthesis, and the second part is the grain filling period, so the end of flowering and between the maturity. And these two periods are mainly characterized by thermal requirements that are necessary to reach, let's say, these thresholds, so the flowering and the maturity. The package offers two types of let's say, phenological development calculation. One assumes only vegetative and reproductive part of the season, where we need to provide some thermal requirements as for example input parameters to reach anthesis and the thermal requirements to reach the maturity. While the other one is more tailored, more for let's say breeding applications, and there we distinguished 6 different subphases of the crop growth. For example, the first subphase would be between sowing and emergence. Then we would go from emergence until tillering, etc., etc. So I will tell you later more about it. This is just to tell you that entire agroclimate service is based on the dynamic approach that is implemented by this, let's say, phenologically driven detection of growing phases. Next, please. This is just to illustrate, for example, if we have different thermal requirements to meet, to reach anthesis and maturity. Maybe I would start on the lower right box when you can see the color scales going from light blue to dark red in the upper right corner. So the color, by picking the color, you can see which would be the thermal requirement in terms of T-sum1. So T-sum1 would be the thermal requirement from sowing until anthesis, and T-sum2, which here is on the y-axis, would be the thermal requirement necessary to reach the maturity, so going from anthesis to maturity. So longer the thermal requirements, of course, longer also the time that is necessary to reach these growing phases. And on the left side, you can see an example of development stage, so how the crop development stage evolves during the season. And if you compare the color of each line, and you find it on the right graph, on the right lower side, then you can see actually to which combination of T-sum1 and T-sum2 this line corresponds. So we roughly start. All the lines start with the same sowing date, which here is assumed to be at the end of November, if I'm not wrong. And then, of course, we go. The first part of season is affected only by T-sum1. And then the second part of season depends also on T-sum2 because this is the one that defines the thermal requirements to reach maturity. And as you can see here, the longest varieties, that would be in the upper right corner, so roughly having 1000 growing degree days of thermal requirements to reach flowering, and then the same value to reach maturity. Those would also result in the latest flowering. And here you could see at the end of July, for example, just to illustrate. I'm sorry, I forgot to mention earlier, on the x-axis you can see the time, and on the y-axis you can actually see the development stage of the winter wheat, starting of course from sowing, emergence, and then going towards maturity. Next, please. These are the time scales actually that I was talking about before. So with the Clisasgri agroclimate service, we aim to build an agroclimate service that is capable of addressing all these time scales. So here we can see that the service that we built is able to integrate already observed climate data, and this enables us to assess the risk based on measured field data, such as phenology, occurrence of pests and diseases, crop yields in the past. And by doing so, we can then also effectively determine the risk thresholds. And then if we go from today ahead, on the x-axis, you can see that there are different climate prediction timescales that we can integrate into this tool. And so going from short-term risk assessment, which is, let's say, integrating the weather prediction up to a few weeks ahead, up to then going towards 1 year ahead, where we can integrate the climate seasonal predictions, etc., etc. So then we are going up to 10 years ahead and up to 100 years ahead, where we can use the tool to assess the climate change impacts. Next, please. This is just the structure of the package, so the agroclimate service. On the y-axis, you can see a group of, so we have 4 different types of indicators. First group aims to assess hydrological balance. The second group, and by that, effectively, we wanted to understand what would be the impact of drought on the crop growth. Then we have a group of indicators from 7 to 13 that is aiming to assess excessive wetness, then cold stress and heat stress. And each of these indicators is targeting different part of the season. So here you can see that we start from pre-sowing period, where we just want to understand, for example, what if there are any droughts or wet conditions during the pre-sowing period that would help the farmers to adapt accordingly for the sowing preparations, and etc., etc. For example, indicator number 6 is a hydrological balance during the entire growing season. And with, for example, heat stress indicators that are also highly important, we aim to address 2 different parts of the season. The first one is between booting and flowering, and the second one is the grain filling, which are both highly sensitive to high temperature. One thing I want to mention, of course, is that all this was, let's say, constructed, developed in a co-design and co-development approach with agronomical specialists, climate scientists, and what is the most important here, also farmers. So this tool has translated effectively the perception of farmers on the climatic events that pose the risks in their wheat fields. Next, please. Okay, this is just, let's say, a description of indicators that are implemented in the R package. Of course, I don't think I will go now into details with each of these indicators. I will share you at the end also the publication and the deliverable of the medical project, where you can see this more into detail. But just to let you know that this is something that has been published and exists, and you can go and check actually what different indicators mean. Maybe here I just present the indicator number 3, which is a climatic, so hydrological water balance indicator. And number 3 represents the hydrological balance during the tillering stage and represents the droughts. And here we also describe the impact that the drought could have on crop growth considered. So during the tillering, the drought can limit the development of root system, and this can lead to decrease in leaf area, leaf number per plant, leaf size, longevity, etc., etc. So all this is available and documented for you for later if you want to go more into details. Next, please. The same for excessive wetness indicators. Maybe I would just mention here that excessive wetness indicators are especially important from a disease occurrence point of view. So if we have more wet days, let's say with rainfall above certain thresholds, 5-10 millimeters, or heavy rainfall days with rainfall above 40 millimeters, there are different, let's say there is an increased risk of different diseases that can occur. Or if we have intensive rainfall days, such as those above 40 millimeters, there is a higher risk of lodging, destruction of canopy structure, etc., etc. So this is all available in a publication that I will share later. Next, please. And the same for heat stress, cold and heat stress indicators. Alessandro, I would like to ask you how much more time I have left, because I think that I'm a bit slow. I'm very sorry for that.
You could have other 10 minutes, something like this.
Okay, so yeah, let's go ahead then. Thank you. Next, please. Yeah. One important aspect. So for each of these, yeah, thank you. Each of these indicators, we have identified a set of possible measures that farmer, for example, can take. For example, if we focus on indicator number 15, which is number of hot days with maximum daily temperature above 28 degrees between stem elongation and flowering period, we can see we have identified together with farmers and agronomic specialists that the seasonal prediction of this kind of indicator could give farmers the possibility to plan the irrigation, give them indication on expected yield, the amount and the quality. So if the seasonal forecast, for example, would give a higher risk of having heat stress, this could reduce both quantity and quality of the final crop yields. And of course, having this information early enough in the season, farmer would have a tool in his hands to adapt to this kind of, let's say, event. So either selecting the variety that would be resistant to this kind of event, or anticipate the sowing to avoid this kind of event during the sensitive stage of flowering. Next, please. This is just an example of seasonal prediction of phenological development. Here we have integrated in Clisasgri a product that predicts the weather or the climate conditions up to 1 year ahead. And this prediction has been initialized, for example, in November 2000, and has predicted the temperature, and consequently we were able to predict the phenological development up to, let's say, the flowering stage, which occurred around, in this case, beginning of May in 2001. The red line represents the actually observed development stage in that year, while the black line represents the seasonal prediction, and the uncertainty is represented by different members of gray lines. So you can see that, of course, we don't really capture ideally with the seasonal prediction the red line, but there are, let's say, elements where we can benefit here in terms of risk assessment and advising to farmers. Next, please. This is an example of application to climate change timescale, and here you can see the plots of the number of hot days during the grain filling period on the left side, and climatic water balance during the entire growing season on the right side. And we compare two periods, the reference one between 81 and 2010 and the mid of century, the mid of 21st century. And as you can see here, the mid of 21st century represents a higher risk of having hot days, more hot days, let's say, between the actually having more seasons with hot days between 10 and 20 during the growing season, but that is mainly because we simulate the same variety in the future, and as a response to growing temperature, the growth cycle, so the period between anthesis and the maturity, is effectively shorter. But that also means that we don't really capture the extreme heat that we would generally capture in the longer, let's say, cycle varieties. Next, please. This is an example, again, of applying the tool in the seasonal prediction point of view. As I said, this is actually the main product also of the MedGold project. So to be able to understand whether we can help farmers in advising, let's say, the decisions to be taken before the growing season actually starts, or during the growing seasons, to help farmers to prepare to unfavorable climate events that would occur until the end of the season. And yeah, this is just an effective demonstration how we integrate actually the observed weather data with the predicted weather data. Predicted weather data here is represented by red spaghetti lines, and observed weather data by the thick blue lines. So in each, let's say, period, we have, let's say, a certain amount of already observed weather data that we can integrate in indicator calculation, and that we complement with predicted weather data for seasonal weather predictions. Next, please. This is an example of application of seasonal weather forecast to European level. Here we have tried to understand when are we able to actually predict the drought accurately, the drought between the heading and the maturity period. So the one that is potentially, let's say, decreasing the yield quantity and quality the most. And effectively, this graph shows us that in February and April, there are large parts of Europe where this kind of, let's say, prediction is still impossible with any kind of skill. But in May, for example, and in June, we can already effectively predict, at least in Southern Europe and many parts of Western and Eastern Europe, with a decent skill, also the drought that is affecting the wheat growth during the grain filling period. Next, please. This is again an example of understanding how different combinations of variety with different thermal requirements to reach anthesis and maturity, how this could result in the number of hot days between flowering and maturity. This is one of the indicators, type number 16. And of course, this is what I was already talking about. Longer varieties indicate that we would also capture more heat stress because we are going longer into the summer. And this is actually what this graph can show us here. Next, please.
5 minutes, Andrei.
Okay, yes, thank you. Next, please. Next, thank you, okay. This is similar, but here we are trying to present an exposure to drought between heading and maturity on the left side, and the heat stress between flowering and maturity, again depending on various combinations of thermal requirements, T-sum1 and T-sum2. And what we can see here, for example, on the right-hand side, is that longer varieties are also exposed. Sorry, on the left-hand side, that varieties can be exposed to varying level of drought that can impact this period, the sensitive period of growth. So I didn't tell you before, but the hydrological balance indicator is a standardized precipitation evapotranspiration index, and if it's negative, it indicates more negative values indicate stronger droughts, and more positive values indicate wetter than usual conditions. Next, please. We have also implemented algorithm that enables the optimal variety selection that is based on prevalent climate conditions. So we would just need then to say which indicators in Clisasgri are important for us in terms of let's say impact on wheat. We select those indicators. For example, in this case, we have selected 4 of these indicators, and we have implemented an algorithm that is then trying to search for optimal combination of thermal requirements during different subphases of crop growth that would result in minimum risk exposure during the crop growing season. I won't go into details here. Again, this is more in detail explained in the publication, and of course, I am available also later for any kind of questions or discussions. This is just to show you that this type of functionality is implemented as well. Next, please. This is a set of functions that are implemented at the moment in the Clisasgri package. And you can get more details on our GitHub page that you can see here on the top. And also, again, these functions are more in detail displayed in the publication. And the main function, of course, is Clisasgri, which actually calculates the set of these indicators. And the other functions are used also to derive some of those graphs that we have shown before, that I have shown you before. Next, please. Yeah, this is now just example of use. You will probably do something a bit different later in dashboard, but just to tell you, so if you download the package on your local computer, you already have a sample data set to play around and an example R file where you can just copy and paste the code in your computer, and you will be able to then calculate a set of these indicators. Also, if you want to select your meteorological data, and if you have your data that are variety-dependent data that are necessary for calculation. Next, please. Yeah, this is just another example. Yeah, unfortunately, I cannot show you now because I cannot share the screen. But as I told you, I'm available later for discussions or any questions. Yeah, I think that now I came to the end of the presentation. So just to a very few conclusions, Clisasgri aims to provide user-oriented co-designed climate service tool that is now actually more tailored for winter wheat producers. It is based on dynamical phenological models and offers an easy way to derive key climate indicators to assess risk and exposure of durum wheat. It allows assessment of past, current, and future impacts on crops and provides farmers with climate information to support decisions at different stages of crop growth. The last slide, please. Next one. So there are some future extensions that we are planning to implement, which is some functionality to assess skill on seasonal to decadal climate predictions that are integrated in the climate indicator calculation. We also plan to directly connect to Copernicus Climate Data Store. Those that are familiar with the Copernicus CDS. We also intend to implement additional crop types and add the functionality to calibrate the phenological model. So basically, this means to calibrate TSUM1 and TSUM2 based on the potential availability of users' field data. And one of the functionalities we have been thinking about is also integration of sowing model that would aim to select an optimal sowing date that is based on preceding weather conditions. So if it's too, we know that if it's too dry or too wet, it's not really optimal to sow. But let's say if we meet some optimal range of conditions, then we can advise farmers, let's say, what would be the optimal window to sow. Okay, thank you. So I think there is one more slide just to let you know that yes, you can contact me whenever you want. I'm available for discussions, ideas. I would be very happy to share ideas with you. Thank you.
Thank you very much, Andrei. Thank you very much. Very clear and detailed explanation about this very useful package. Thank you very much. I don't know if there are questions for Andrei. So please don't be shy. Yes, please.
Yes, good afternoon, everybody. So thank you very much, Andrei, for this interesting and rich presentation. So I have a question about the threshold of indicator. So can you explain, please, the methodology you used for specifying this threshold, and if this threshold can be extrapolated for over the Mediterranean area, especially the southern side? I mean by this North Africa countries. Thank you very much.
Thank you for the question. Could I ask you again just to which threshold did you mention? I didn't catch that part
Yes.
of the sentence. It is a threshold for one specific indicator, temperature-related indicator. Am I right?
Wafa, I suppose you are muted. So
Yes, I mean the threshold for some indicators.
Okay, in general. Okay.
Yeah, in general.
Yes. So this, thank you for the question and thank you for the comment. These questions were, these thresholds were determined based on actually 3 levels of information here. The one that we, let's say, appreciated the most was actually the feedback from the farmers that we got here. So, for example, for heat stress indicators, the general idea from the literature that we would get would be that around, let's say, anthesis phase, the temperatures around 31 degrees are for wheat are those that are more dangerous for exposure to higher risk. However, the durum wheat farmers from Italy told us that it's already 28. Not only durum wheat farmers, also the agronomical specialists that are working together with the farmers told us that it's already 28 degrees, let's say, something. So it considered as a temperature threshold that could be that has a potential to lower the yield at the end of the season. So not only the quantity but also the quality. The same goes for the precipitation-based thresholds. So this was again determined together based on literature review, and then reviewed together with the agronomical specialists and farmers. And we found a kind of consensus in this co-development approach together, which kind of thresholds could best represent, let's say, their perception of climatic risk in the fields. And as such, it is applicable, of course, to entire Mediterranean area. Clearly, I need to emphasize also this, that it can depend, of course, this threshold is more a generic type of approach, threshold-based indicators. But of course, if we are growing more heat stress resistant varieties or drought resistant varieties, then this means that the 1 or 2 days of exceeding, let's say, this maximum temperature, that maximum temperature would exceed this level, wouldn't really pose a big level of risk for wheat growth. But this is actually then where the field data, which you would have available maybe from your field experiments, would come into the place. So we can. So the Clisasgri is a climate risk, basically climate risk indicator tool. So it calculates a risk. But then this can, if we do it for the past weather situation, we can always try to understand by doing some simple modeling or comparison with real situation like the yields or different crop parameters in the past, what would be the level of threshold actually that is more specific for a specific situation, let's say, or specific wheat variety or specific location in other regions of Mediterranean, for example.
And
thank you very much.
Thank you, Andrei. And there are two questions, one by Tony. Please, Tony.
Hi, Andrei.
Hi,
really interesting presentation. I'm really impressed by this tool. I have, could you go back to slide number 10?
Yes, just a moment. Slide number 10 over there. Yes.
I wonder how Clisasgri accounts for different timing of crop stages based on where you are in Italy, where you are in Europe, and I wonder, did you do any assessment of how accurate your forecasts are?
Yes. So the development, the crop, so basically the model that we implemented, the phenological model, is mainly dependent on, I think it's 4 parameters. So we have the thermal requirements to reach anthesis and the thermal requirements to reach maturity. This is the TSUM1 and TSUM2 that I was talking about during the presentation. But then there are also some day length related requirements that affect the phenological development and vernalization requirements for winter wheat. And these, of course, are spatially highly dependent. In Europe, we have, for example, performed spatial calibration of this model, of the phenological model, that is based on roughly, don't know the number, but it's above 50,000 data records that we have had from the field experiments we have collected during the years and during different projects in Europe, from the field experiments, from observational data, from the field campaigns, etc., etc. So we were able to get our hands on quite a large data set. As I said, I think it was around 50,000, and this data set contained the values of observed sowing dates, emergence dates, for example, and then also observed flowering dates and observed maturity dates. And by having this data set, we were able to do 2 things. First one is do the zonation of Europe in terms of, let's say, homogeneous wheat variety representation. So where we would assume, of course, that we have, let's say, a certain family or group of wheat varieties that would have a dedicated thermal and vernalization requirements. And then we use the same data to calibrate the phenological model, so to determine actually the TSUM1, TSUM2, and the vernalization requirements for all the regions in Europe. Of course, this is highly approximative. If one wants to do this on field level, let's say for his own application of the package, then of course the best thing to do is to calibrate the phenological model specifically to represent that variety. But if we want just to assess, let's say, the quality on the continental level to see if this tool can be useful also to inform a bit more large scale, let's say, related applications, then we have seen that by calibrating the phenological model and doing out of sample validation performed quite well actually for those data sets that we had available across Europe. In the second study that is actually now also still ongoing, we have tried to understand whether the climate prediction, seasonal climate prediction, can effectively be integrated into this kind of, let's say, tool. So also to drive the phenological model, but in this case, the phenological model that is calibrated based on preceding observation data that I described before. And in this case, then we were interested only in the skill of seasonal forecasts to predict the phenological stages that are determined by the observed data. And yeah, here we have seen quite some encouraging results, of course, depending on the region, on the Europe. There is more or less skill available to benefit from the seasonal surface climate prediction. Also, let's say, I don't know, 7 months ahead, if we are talking about using these predictions already in autumn. But clearly, this kind of predictions improve during the season. So with two reasons, of course. No? We have, let's say, shorter growing season ahead of us, which means that we, in theory, also have, let's say, climate predictions that are more skillful. And we have, let's say, more and more observational data that is already integrated, as I showed in one of the graphs, in the calculation of phenological development. Maybe I complicated my answer too much. I apologize for that, but I hope that I answered approximately your question.
Yeah,
Thank you.
Thank you.
Thank you.
Next question by Alvin. Please, Alvin.
Yeah, also thank you for the presentation. And I was wondering, I think on your last slide, you really emphasized the connection to growers, like this co-development. And I was wondering, how do you envision to use like an actual farmer the tool? Is he using the tool directly, or is there some kind of a crop consultant in between? That you kind of look at the graphs together and then decide for the location what to do, or
Yeah, thank you, and thank you for the question. This is a very important question, of course. So I guess there are two things that I would like to emphasize from this experience. The first one is that by including farmers in the development of such kind of service, we also increase the probability that they are going to be willing to use it, no? Because they feel that they are a part of the development process. And moreover, we are also implementing what they think is, what they perceive as, let's say, event that poses a risk to crop growth. We, of course, are, let's say, more scientists. We sit in front of computer, but they are the ones that are working in the field every day, and they know, let's say, what kind of weather they are experiencing and what is risky for them. And that's why I also very much appreciated this from my side, let's say, as being kind of agroclimate, let's say, scientist on both sides. And the second one, yes, of course, this is a tool that should be used by kind of, as you mentioned before, an expert, agroclimate expert that directly advises then farmers. So that the one that is then in touch with farmers during the growing season, that provides him with direct advice. Now, of course, we cannot expect from farmers to use this tool directly because it's definitely too complicated and it's not meant actually for them to be used. But let's say this is also then a business opportunity for agroclimate services, let's say, to deliver this information and added value to the end users, which in this case are farmers.
Thank you. I don't know if there are any other replies from Albin. Otherwise, final question by Rosanna. Please, Rosanna, very quick question because we are just a little bit for
what is a very good presentation, and what is the measure of accuracy to forecast, the type of model used by forecasting, and the information for farmers is linked to time. The forecast is a monthly forecast, daily forecast, annual forecast, and so on. Okay.
Thank you. So the forecast we are talking about is the seasonal climate prediction that is available in the climate data store of the Copernicus climate service. So concretely, in this case, we have analyzed the CIS5. So this is the the system fifth generation of the ECMWF seasonal forecasting system. The seasonal forecasts are issued at the beginning of each month, and they cover the period up to 7 months ahead. So what seasonal forecasts deliver is the daily data, actually, as you mentioned correctly, the daily data up to 7 months ahead. And in this case, yeah, it's available, I think, on 1 degree spatial resolution. And of course, it doesn't cover only Europe, it covers entire globe. And this seasonal forecast comes in an ensemble of 25 different members that correspond to perturbed initial conditions. I'm not sure, was there also another question related to seasonal forecast?
The measure of accuracy of to forecast.
Okay.
Because
to measure the accuracy of the forecast, we have used three scores, let's say. The first one is the fair ranked probability skill score. Then we have used the reliability, and then we have also used a simple correlation. And yeah, this is still analysis that is ongoing, and I will also in the future, I can share with you the results of this analysis.
Okay.
Thank you very much. Thank you very much, Andrei, and
thank you
very much for
thank you for inviting me. It was a great pleasure to have this presentation and discuss with you.
Thank you very much, Andrei, and you know that we are very exciting to think about the possibility to include the other crops indicator in Clisasgri, because I know that you are working on that, and I'm sure that in the future we'll have also other very exciting indicator included in Clisasgri. Thanks a lot thank you for your presentation. And so, thank you, Andrei. Now it's time to go to the second presentation of this day. This presentation is about the MedGold dashboard that we have already start talking about the MedGold dashboard. Let me just very briefly introduce the main concept of this tool. This tool has been developed completely by MedGold, and this is a visualization interface, and I would say it's something that could translate the climate data mainly from Copernicus Climate Data Store, but not only, into something that could be useful and usable from the users. In MedGold, we have developed this tool at the beginning for the wine sector and for the olive oil sector. So here you can see some example for the Iberian Peninsula, because the main focus of this service, as you can see later in the next sessions, is on the Iberian Peninsula. But in the next weeks, I suppose, or even next days, as also Andrei anticipated, we could have also some indicator for the durum wheat for Italy. And this tool has been really co-developed and co-designed by providers and users, because since the beginning we have had a very strong and very heavy interaction with our users, starting from Sogrape, so from the company by Antonio Grassa in Portugal, and even with the COP, the cooperative in Andalusia, for the overall co-design and for the main feature that should be presented in the dashboard. But now it's just time to have a look at the dashboard. As you may likely already know if you have had a look at the info sheet that we have prepared or the video or something like this, we have three main tabs in the dashboard: one on the historical climate, one on the seasonal forecast, and one on the long-term projection. And starting from the historical climate, you could understand which kind of changes in the climate, in the mean climate state, is already ongoing, starting from the recent past. In the dashboard, we could have some historical climate data. One data set is mainly focused on the Portugal and the Douro region in the northern part of the Portugal. It is PTHRS data set. It is provided by University of Trás-os-Montes and Alto Douro, explicitly for Met Gold, so this is not a freely available data set. This is a sort of downscaling of EOBS data over the Portugal with 1 kilometer of spatial resolution, so very high resolution. Unfortunately, this data set stops in 2015, so we don't have the final years of the video. It cannot reach the present, and that's the reason why we have also included, not only, but it is one of the reasons why we have also included ERA 5 dataset in the historical climate data tab of the dashboard. So in the dashboard, we'll have data from 1979 up to the present. In the dashboard, you can find data up to 2020 with a spatial resolution of 30 kilometers. And here, so far, but in the next week, we could have also the Italian Peninsula, but so far, the dashboard is focused on the Iberian Peninsula. And ERA 5 dataset is provided by the Copernicus Climate Change service through the Climate Data Store. And you could find in the dashboard different kind of fields. The first one is the essential climate variables. So you can have a look at the mean temperature, the maximum temperature, minimum temperature, precipitation, and in the dashboard as reported monthly data for each year, or the climate average over the reference period 1981 up to 2010 that we can use as a reference period. So you can have here the switch between the data and the average data. For the bioclimatic indicator, here is reported only the wine service, the bioclimatic indicator for the wine service, but there is also a number of indicators for the olive oil service. Here there is growing season temperature, spring rainfall, harvest rainfall, summer days, and water spell duration index. And in the dashboard, you can also find the definition of each of these bioclimatic indicators. For the olive oil sector, you can find the maximum temperature of spring, the winter precipitation, the number of days in spring with temperature higher than 32 degrees, the summer days with temperature above 36 and 40 degrees. And also for the bioclimatic indicator, you can find the data for each year or the climate average. Finally, for the wine sector, we in Met Gold we have developed two main compound risk indexes. One index is about the pest infestation, so the possibility of having the necessity of having more sanitary treatment than usual. And for this sanitary risk index, the main source of risk that we have identified with the users with Socrates is high or low, very high or very low spring rainfall, high harvest rainfall, and in general, growing season temperature below the normal. While for the heat risk index, so it is related to the heat stress of the crop. The main source of risk are for sure value higher than normal for warm spell duration index, for summer days, and for growing season temperature. However, you can find all the details in the info sheet and in the material of MetGold. Which kind of information you can obtain from the dashboard? Let me remind that you have already, you should have already received the credential for have access to the dashboard. Please, if you want, please have a look and start playing with this kind of tool. It could be useful for you and also for the feedback that you can send back to us. We are talking about the kind of information that you can obtain. You can obtain maps for sure, that and if you click on a selected grid point, you could obtain the time series of the requested variable that you have selected. And very important for the users, and could be also useful also for you, you can export this kind of data, and you can download this data as ASCII file, so TXT file, in this case CSV file is some kind of ASCII file that could be readable by a standard software like Excel, for instance, or you can export like an image, or you can also obtain the time series like ASCII files, text files, or with an image. And this is very important for the users because, as also Antonio remarked in the previous session, the CDS is not so user-friendly for the end users. Maybe the CDS is more focused on the interface layer, so for consulting cooperatives, consulting companies, or for someone that could provide the final information, but it is a general infrastructure that could be not so accessible by the users, while in this case, the users could directly download a very simple file for their own business. But for sure, we don't have only historical climate, but we have also seasonal forecasts. For the same kind of variable. And as Andrei already said, we have prediction 7 months ahead, and for the climate variables, and we have also the bioclimatic indicator and risk indices at the same time horizon. The temporal resolution is monthly data, and for this kind of prototype, because the dashboard is only a prototype, please keep in mind this aspect. We have a frequency of update monthly for the time window from March to June. After June, it is not planned to update anymore the dashboard in this phase of realization. And from the seasonal forecast tab, you can update this kind of map. This is a map with the so-called dominant tercile. So you could have information about every field. In this case, for instance, is the essential climate variable, is Tmax. And you could have the information by system 5. So as Andrei already said about the operational seasonal forecast from CMWF, from the European Climate Center for weather and midterm forecast, and you get information if the most likely tercile for this variable is below normal, normal, or above normal for a specific year. And so the idea is that we have downloaded from the CVS a number of possible seasonal forecasts from System 5, and we have simply counted the number of realization of the forecast where the temperature is above normal, normal, or below normal, and here is reported which is the most likely tercile. So, which is the most likely probabilistic forecast for a specific month. And for each grid point, you can select a specific grid point, and you can obtain the time series here reported. This is just an example, and this is, for instance, the forecast for June, for the month of June for Tmax. And here, for a specific grid point, you can see that there is a time series. The blue circle is the observation by ERA 5, while the colored square are the most likely tercile obtained from the seasonal forecast for the past, starting from 1993 up to the present for this specific grid point. So you can have so far an idea of or which is the hit rate, so which is the possibility of having success in considering the seasonal forecasts for a specific grid point. And so you can see the historical observation, so the blue circle, and the square is the seasonal forecast. And so you could have another way to have an idea of the accuracy of the seasonal forecast. The first one, as I said, is the qualitative. So looking at the historical, you can look where and when the observation and the prediction matches. And or we have also another possibility. There is you can apply a skill mask that could remove the grid point where the seasonal forecast does not add any kind of value with respect to the climatology. So this is based on a very common metrics for seasonal forecast, is RPCC score, and you could have also a look at this kind of metrics in the dashboard or in the material, the technical material attached to the dashboard. And yes, this is the example. Without the skill mask, you could have a general map for the Iberian Peninsula. And with the skill maps, only the grid point where the seasonal forecast could actually provide an added value with respect to the climatology as showed. Finally, for the long-term projection, we'll have only climate variable and bioclimatic indicators. This is directly due to a specific request by users. The users are not interested in the compound risk indexes that we have developed for historical climate and seasonal forecast, even in the long-term projection, but they are more interested in the bioclimatic indicator. And we have reported over there two different time windows. The first one is the middle of this century, so 2031 up to 2060, and the end of the century, the 30 year at the end of the century, with the reference period based on the 1971 up to 2000. And we have used a subset of Eurocordex simulation. Eurocordex is a in an European initiative about high resolution climate projection over the European domain. This projection is the native grid is 12 kilometers, but for this specific for the dashboard and explicitly for the Douro Valley, we have downscaled this information up to the resolution of 1 kilometer from the PT HRS dataset that we have talked at the beginning of this presentation. And while for the Andalusia, we have used the EOPS data at 10 kilometers. So we have two different resolutions for the two main areas of interest for the climate projection. The Douro Valley is at 1 kilometer, while the Andalusia, more interested in the olive oil sectors, just to be clear, is at 10 kilometers, more or less. And we have the two represented in climate pathway, the RCP 4.5 and 8.5. So this is more or less a very quick overview of the dashboard, but for sure you could you have access to go directly in the dashboard, as you can see over there, and just a very live demonstration, for instance, and you could play and you could try to obtain map and data, and also export data for the problems that you have to cope with in this living lab, or for your pleasure. For instance, this is, the seasonal forecast for the maximum temperature for next June, for instance, for this month, with the starting date of the seasonal forecast by April, but we can also select, for instance, May. And we have this kind of dominant tercile map. And if you want to have, if you are interested in some point all around the Portugal, you could obtain the time series that we have already presented. So more or less, this is a very quick overview about the dashboard, and I'm here available for question or for doubts or comments about this. Thank you.
Sandro?
Yes.
I have a question.
Yes, sure.
Thank you very much. It's very interesting platform. Just I have a question. Is it possible to use a different area over the Mediterranean?
So in this prototype has been developed only for the area of Iberian Peninsula, and in the next weeks for the Italian peninsula, because this is just a prototype and it is based on the interest of the service, the pilot service in MedGold that is focused in the Iberian Peninsula and over Italy. But for sure, in the future release of the dashboard, no objection in principle to have a wider area of interest, but we have to understand which is the main purpose, and we should be the main outcome, and we should be the users that could be interested in this. But for sure, there is no objection for a further extension of the domain of interest of the dashboard. But so far, it is only for this area.
Thank you.
Thank you, Maria. And are there any other question or comment?
I have one question.
Yes, yes, sure.
I'm just curious because I mean now you have the MedGold project, and then I guess it ends in some year in the future, and
Yes,
is kind of
in
like
about 12
maintaining these.
months.
Okay, yeah. So is maintaining these platforms in the future, is it even possible if the project is done? Is it very expensive, or are there any avenues of like having continuous funding for it?
Thank you very much. This is a very relevant question, and thank you very much for this question because I could take the opportunity to spend other words about this. For sure, this prototype could have a future if the users, for instance, could have a specific interest in keeping alive this tool. For instance, there are specific tasks in MedGold project about the commercial exploitation of the dashboard, because for sure one possibility is that our users could pay money to keep alive this service, maybe to a more mature stage of development closer to the market. So at the operational level, so far it's just a prototype, but in the future, our main ambition is that this kind of prototype should be keep at operational level with the specific interest and money by the users. The other possibility is to have the possibility to include this dashboard in the wider framework of Copernicus, and this is another possibility, and we are just talking about this with Copernicus. But for sure, this is one of the key aspects for climate service, because this dashboard has a cost. Is about more or less about 1,000 euros per month, more or less, so far at this level. But maybe if we have to develop something at operational level, you have maybe to increase something, and so. This is something that should be taken into account when you are talking about climate service, because the users should understand if this kind of cost for them could be something useful or not. And this is the reason why your question is very, very relevant for this kind of service. I see in the chat that Christine, you didn't receive any credential. Please look in your mailbox, because you should have received something last week by Lutec B2B team. This is our ICT partner in MedGold. Maybe just double check and then let me know. And is there any other comment or question?
I have
Please.
one, like a kind of a follow-up to this funding question, because I guess if you reach out to people and try to get funding for it, how do you kind of share or like communicate the effectiveness of the platform? Like, do you talk about like monthly users, or do you make an interview with growers in your network and kind of ask them if they
Thank you very much. This is another very relevant question, and maybe the best answer can be found in the other path today, because they have talked about the commercial viability of climate service, and in this initiative. Keep in mind that we are talking about a research and development project and research and innovation project, sorry. And here we have taught to some training for the users just in these months. So just now we are talking in Sogrape. There have been some training about the use of the dashboard, and in the next weeks there will be some interview and some survey with the users involved in this process. And the same will happen also with the COP in Andalusia. And for sure, the most important thing is to assess the added value, as you said about this kind of service, because you should make the users at least able to understand if the cost of this kind of tool, or in general of a climate service, could be something that could be useful to pay in the future, and it's going to be something that could be a good investment for the company. And for sure, one of the key aspects is to go to the past and to understand which kind of key decision for each company could be affected by this kind of information in the past. Sorry. And so this is one of the key aspects for climate service, in my opinion, because at the end, a climate service, especially for the business purpose, as the dashboard could be, because now is focused on the European domain at the European level. The idea is to have something like a real market for climate services. So a relevant part of the climate service outcome could be part of a market and of a business. So the key point is to assess the added value, for instance, with the interview, with survey, as also to some specific report on specific key decision for the users. For instance, the problem that Antonio Grasa presented over there in the first end-on session for the wine sector is something that could be definitely a good practice for users to understand if this kind of investment could make sense or not. I hope that it could reply to your question.
Yeah, thank you a lot.
Alessandro?
Yes.
Yeah. I have also a question. So if you want to establish a similar platform at national scale, for example, is it possible to share with us the code?
Yes, yes, for sure. The code and all the software that we have used to develop this kind of dashboard are free and open source, and at least after the after that the European Commission accept the deliverable and all the outcome of the project, all this kind of also not only the data but the software could be available in a free Git repository. Is a cloud-based platform, and is cloud-based architecture based on Amazon Web Service, and all the code is free and completely open source. So in principle, it's possible to replicate this tool over other domain for other specific areas.
Thank you very much.
Okay. I think that the time is running out, and if there are any other questions, please let me know and step in for a final question. If it's not, oh, please, Tony.
I wanted to ask sort of a follow-up question from what Alvin asked. Do you have a sense for how long it would take for MetGold to become sort of an operational tool that is integrated in decision making? And do you have an example from the past, a climate service from the past that went through the same kind of development as MetGold, that is now part of, I don't know, Copernicus, or that is sort of commercially available?
Well, I would like to distinguish between Copernicus initiative and commercially and other outcome that could be more commercially exploited, because the Copernicus outcome are mainly demonstrators so far, even if at operational level, but is demonstrator. In my experience, I don't know how many application at European level so far have been used by users. Maybe there is something for energy sector. I'm not sure about agricultural sector. And so this is one of the first initiative that put this kind of outcome quite close to the market. Just to reply to your question, I think that in principle, if you have a very clear definition of the user needs, and also to the which kind of information you already you need, I think that the time to give this prototype operation should be around 6 or 9 months, nothing more. But you should have all the other steps already done. So in terms of user requirements and to definition and to the co-design of the tool and so on. If you want to start from this kind of prototype and make it operational, I think you need more or less between 6 and 9 months. And then should be some testing phase. And I think that less than 1 year, you could have something at operational level. But I'm not sure that something similar to this already exists, at least at European level.
Thanks.
Okay. I think that for sure we could have all the discussion on the dashboard, and you can find all the material of the dashboard and on Clisagri in the web repository of the Living Lab, and for sure I would encourage you to use it. And I have seen that Christine cannot find this her invitation, and now I would ask to our ICT team to resend to you the credential. And so please have a look at your mailbox, especially for the mail that you have indicated as your main contact. I think that this session is now about at the end. We will reconvene the plenary session on Thursday morning for Central Europe summertime. You will receive all the reminder and all the link for the plenary session. And I would also encourage the teams to start thinking to how to cope with the problems that you have received about the three sectors of MetGold. Now, so far, you have also other practical tools like Clisagri or the dashboard that can be useful for your purpose. And thank you very much for for your attention. And okay, Masi, I'll remain here a few seconds. And thank you very much. And we will talk again on Thursday. Thank you.
Bye bye. Also, Alessandro.